Often when we're developing a computer program, we realize that there is a task or a set of instructions that we need to execute over and over again. And in fact, this is a big part of what makes computers so powerful, is that they can take a task, whether it's trivial or something really complex, they can do it pretty quickly, often very, very quickly, and then they can just do it over and over again, and computers never get tired, so they can just do it as many times as they need to do it. And for example, we might be looking at a student's percentage in a course, and we want to determine what their letter grade is, right? And we can use, for example, an if statement to do that. We can say, well, their grade is higher than 90, so that's an A, and so on. If you have an entire class of students, it's going to be the exact same determination or calculation for every single student, right? And so what we want is we want to take that little code that figures out their letter grade, and we just want to do it with every student in the course. To do something like this, we're going to use what's called a loop. And that's what we're going to take a look at in this video, is the basic concepts of what a loop is. Simply put, a loop is a block of code that's going to execute repetitively based on a Boolean expression. And so hopefully you remember that a Boolean expression is something that evaluates to true or false. And so for example, the person is over the age of 18. That's either true or false, right? That's a Boolean expression. If the expression evaluates to true, then our loop is going to execute again. And if and when the Boolean expression comes back as false, the loop's going to stop. We're not going to execute that code again. We're just going to keep going on with the rest of our program. And so we have, often we use flowcharts to kind of demonstrate or visualize this kind of thing. And so the program execution comes here. It's going to take a look at a Boolean expression. Let's imagine we're writing a simple program that's just going to count from 1 to 10. And so it's going to essentially ask some version of the question, are we still counting? Well, if we are still counting, it's going to come over here, count up to the next number, print out that number, and then it's going to come back, ask itself again, are we still counting? Yes, we are. So it's going to repeat the process again. And eventually it's going to be done. It's going to be at 10 and it's going to come back false. And so the program is just going to continue on with execution from there. This kind of a loop, we can talk about this as saying that we're checking the Boolean expression first and then we're executing the code. And that's probably the most common type of loop that we're going to create. But there are other types. So for example, we can run code first, and then after we run the code, we can check and see if we want to go back and do it again. And that's less common, but it is still useful, and we do still often have a need for it. The difference is, or the way we decide which one is better for us, is do we have to run the code at least one time? Does the code have to run once just to kind of get us started? If that's the case, then we want to run first and then check. So some examples to make that maybe a little more clear is, imagine we're writing a program and we have to make sure that the user is authenticated, that they've typed in their password or their PIN or whatever we're using to check that they are who they say they are. So in a check first approach, we're just going to sort of ask the question, is this user unauthenticated, right? Do we not know who this is yet? If that's true, meaning we haven't authenticated them, then we're going to go into the loop body. We're going to ask for their password or their PIN number, or we're going to scan their biometrics or whatever. And we can keep doing that until they get it right. In a run first approach, then we're going to start by checking their authentication. So we're going to start by asking them for their password. And then we're going to check and see if they are now, if they're still unauthenticated, then we're going to go back up and execute that again. In order to talk about these loops, we're going to need a little bit of terminology here so that we can get on the same page. And so we're going to refer to a single execution of that block of code as an iteration, right? We're going to say that if we're counting from 1 to 10, each number is one iteration, and so we are iterating 10 times. And we can, based on that, we can kind of categorize loops in two different ways. There's a definite loop, which is where before the loop starts, we know how many iterations we need. Okay, that's a definite loop. An indefinite loop would be a situation where at the time we start executing the loop, we don't know how many times it's going to need to iterate. As an example here, that's not really computer programming, but let's think back to the last time we were in a high school PE class and the PE teacher takes us out to the track. If the PE teacher says run 3 laps, that is a definite loop, because before we start running those laps, we know that we have to go 3 times, right? Each lap is going to be an iteration. An indefinite loop would be something like the PE teacher telling you to run a lap and keep running laps until your heart rate is 160 or something like that. So you're going to run 1 lap, and as you start, you don't know, well, I might be done after this 1 iteration, or I might have to go 5 times. I don't know. So you're going to run a lap. At the end of the lap, you're going to check your heart rate, and then you're going to decide if you keep going. So in an indefinite loop, we might not know, well, we don't know how many times we're going to have to execute, how many iterations we're going to need. Another term we're going to want to be familiar with is the idea of an infinite loop. And so an infinite loop is a loop that will execute forever. Sometimes we do that intentionally, and often we do that unintentionally as a bug when we're writing our program. And if we go back to our running track analogy, an infinite loop would be something like the teacher says, well, keep running laps and I'll tell you when to stop. And as you start running, you see the teacher walk off, he quits his job and hops in his car and goes home. And now you're stuck just running laps forever. So that's maybe not a realistic example, but that is an example of an infinite loop. A couple other terms we're going to need to know. We use the term control variable to refer to whatever variable we're using to determine whether or not the loop keeps going. And there are a couple different ways we can do that. One real common thing we often use with a loop is a counter. And so a counter is a variable that keeps track of the number of iterations we've executed so far. And often we use that as a control variable. So in our track analogy, we would have a counter that is the number of laps we've run. And so it starts at 0. We run around the track, and at the end of the first iteration, at the end of the lap, we're going to add 1 to that. And then we're going to say, okay, well, do we need to run again? And we're going to keep going until we have met the requirement for how many times we need to iterate. That's an example of a counter variable. They're not always used to control the loop. Sometimes we have a counter that is part of maybe like an indefinite loop, and we just need to know when we're done how many times we iterated. A term that I don't use as often, but you do hear it, so I want to mention it, is a flag variable. And so usually when people use that term, they're talking about a Boolean variable that they're using to control their loop. And so, for example, they might have a Boolean variable that's, is unauthenticated, to go back to my password example. And so they're going to set that to, or I guess I should use the track example, is less than 150. I don't remember what I said. So at the end of the lap, it's going to check your heart rate, and if it's going to be Boolean, it's going to be true or false whether or not your heart rate is above that number. And that variable, once it becomes false, is going to be what stops the loop. In our password example, our authentication example, if we're basing our loop iterations on this variable that is, whether or not they're still unauthenticated, then once we turn that to false, then the loop's going to stop executing. So a flag variable is another kind of control variable for a loop. And as we talk about these control variables, we'll go back to the idea of an infinite loop. One of the main reasons, especially beginners, but I do it too sometimes, get an infinite loop, accidentally an infinite loop, is when you forget to change that control variable. So if you're in a gym class running around the track, I don't think you're going to forget to add 1 to the number of laps, but you'd be surprised how easy that is when you're writing code, where you forget to say, okay, we've done another lap. And so that number of laps variable stays at 0, and that poor kid just keeps running forever, right? That's an example of an infinite loop, and I'm guessing that you're going to accidentally do that at some point over the next few weeks. So that's another place where this idea of a control variable comes in. That's given us a basic idea of what loops are and some vocabulary to talk about loops. And so that's a good introduction and a good place to stop before we jump into actually writing some loops using source code.